You are listening to the voice of Alan Shapienez, co-founder and architect of Neptune, bringing scalable privacy to money for the next generation. In this video, I will be talking about the key privacy-preserving aspects of Neptune. What techniques does Neptune employ to serve user privacy, and how do they affect scalability? Transparent ledgers are terrible for privacy. Opaque ledgers address this deficiency by concealing or somehow obfuscating the transaction graph. They do this without sacrificing auditability, as you might expect. Special zero-knowledge proofs give the auditor a cryptographic assurance that the books check out, the balances are positive, and that there is no inflation, while hiding all other information. The use of zero-knowledge proofs for this purpose is known as confidential transactions, and all privacy coins use it. But just using confidential transactions is not enough. You also need to conceal the transaction graph, which shows the origins and destinations of transactions. Confidential transactions hide how much is being transferred and how much is being held, but the transaction graph gives you which address a transaction originated from and where it's going. So all privacy coins need some other mechanism in addition to confidential transactions to conceal the transaction graph. And this point is where various privacy coins have different constructions with unique trade-offs. With that preface out of the way, let's return to the question at hand. What are the key privacy-preserving aspects of Neptune? In Neptune, there are four mechanisms that serve privacy: confidential transactions, the mutator set, transaction mergers, and lightning. Confidential transactions. Like all privacy coins, Neptune uses confidential transactions to hide amounts. But what sets Neptune's confidential transactions apart is the commitment to the amount, which is just its hash digest. The drawback is that this digest is not homomorphic, and that complicates the zero-knowledge proof part somewhat. But the advantage is that it is post-quantum secure, and so even when large-scale quantum computers are built, they will not be able to undermine privacy nor generate undetectable inflation. Mutator sets. The mutator set is what breaks the link between inputs and outputs of transactions. It is a cryptographically authenticated database, not too dissimilar from a Merkle tree, but more powerful. You can put UTXOs into the database, or you can take them out from the database, provided that you previously put one in. The special selling points are: A, the operation of adding and removing a UTXO are unlinkable to each other from the perspective of external observers, thus generating anonymity. And B, the workload of all parties involved scales polylogarithmically in the number of transactions. This is what supports the scalability part of Neptune's claim to scalable privacy. Mutator sets are an alternative to decoy and nullifier sets, which is what most other privacy coins use, including Zcash and Monero. This construction does not scale well because the nullifier set grows linearly with the number of historic transactions. It grows indefinitely, you have to drag it around regardless of its size, and you can never truncate or compress it. Transaction mergers. What happens when you have a large sledgehammer general-purpose proof system such as Triton VM is that everything starts looking like a nail. In Neptune, you can bundle transactions and replace their signatures with a single Triton proof that the original signatures were valid. And you can bundle bundles of transactions too, proving instead that the original proofs were valid. In the end, every block contains just a single transaction, which represents the merger of all the transactions that the miner decided to confirm. This construction benefits both scalability and privacy. Scalability comes from the fact that on the margin, 0 bytes of scarce blockchain space are wasted on witness data such as signatures. Privacy arises from the coarseness of what remains of the transaction graph after merging transactions. The attacker can still get the original fine-grained picture, but only by running an online node and logging the transactions as they are broadcasted, not by reading the blockchain. Lightning. Lightning is the collection of channels consisting of jointly owned UTXOs whose balances can be updated through private communication between the parties. It forms a network because it can atomically route payments between nodes who don't share a channel, as long as there is a connecting path with sufficient liquidity. The blockchain is only needed to open channels and close them. Lightning benefits both scalability and privacy. It benefits scalability because transactions are no longer competing for scarce blockchain space. 2 transactions can take place simultaneously without interfering with each other. It benefits privacy because no information about the transaction needs to be sent to anyone who isn't a party to it. In particular, the blockchain records no trace of the transaction precisely because that transaction is kept off-chain. If you are as excited as I am and want to learn more about Neptune, the best resource is the website, neptune.cash.